Here we have coaxial cable. In coaxial cable we have two wires. The shape is cylindrical. We have inner wire and outer wire. The inner wire, the current is basically going upwards, and an outer wire current will be in the reverse direction. So we have to find induced self-inductance, basically L. So how can we find it? First of all, we have to draw the imaginary line where we have this kind of things, and we also have a radius of this wire. So we have A, which is inner radius, and B is outer radius. Okay. If you have selected this such a rectangle shape, and the length of the wire will be given, or it's unknown, and then at a certain distance the inner wire will create a magnetic field at certain distance. So let's say this is a certain distance, R or X, as this is shown here, and then that one will make self-inductance, which is very small. Okay, and this is your area. Your area will be very small, which is dA. Okay, dA will be small area, which is equal to the length of the cylinder, and dx. Dx is that small distance, which is dx. Okay, and so that means dA is equal L dx. The first formula that we're going to use will be the flux, which is equal inductance multiplied to current. Okay, this is your first formula. The second formula will start from the beginning, where B is equal, when you have single wire, the B will be equal mu naught current divided by 2 pi R, which is all 2 pi X. So this is your second equation. Now we want to find this flux in this small, very small area. Okay, this is in small area, this is small area, which will be equal to dF over dBA. Then we know the magnetic field will be constant, so we brought out from the D, and we end up with B times dA. Okay, and your B is equal to the first equation, which is mu naught I divided by 2 pi X. X is any distance, so we bring it here, and we end up with mu naught I divided by 2 pi X times dA. Okay, then we have to integrate both sides, dF and also the right side of the equation. So integral of dF will give you flux, and integral of this whole things will continue. The limits will be from A to B, because radiuses are given, and after working out this one, you will get mu naught I L 2 pi and dx over x, and integral of dx over x gives you ln x, and then you have limits B and A. So you put the numbers, and you will get mu naught current L divided by 2 pi ln B over L, and this one is also equal to the L times current, and this current with that current cancels out, and the final formula will be L is equal mu naught L divided by 2 pi ln B over A. That's it.